When you add and subtract fractions with unlike denominators, like these, you have to first get a common denominator, and you usually want to look for the lowest common denominator, LCD, lowest common denominator. You can get any old common denominator, but the lowest makes things a lot easier in the end. So what we're going to have to do for both of these fractions is we have to get a common denominator. Okay, here's how we want to start this. There are different ways people have been taught on how to find the LCD, especially when you have terms like this and not just simple numbers. So what I like to do is I like to take one of the two terms and just start with it. So I'm going to take the first term. That would be 6x. The first denominator is 6x, the whole thing. And I look at the second one and I go, what is one number that 6 and 4 both go into? Just focus on the numbers first. One number that 6 and 4 both go into. Well, you could just multiply 2 and say 24. Yeah, that works. But is there something smaller? You would think for a while. You hopefully will come up with the idea of 12. 6 and 4 both go into 12. And how do you change a 6 into a 12? You need 2. So 6 times 2 would be 12, and 6 and 4 both go into 12. Second of all, I need something that x and x squared will both go into. And so hopefully you could catch on that. That'd be x squared. So I need another x. So hopefully you catch on that it's 6x times 2x is going to be 12x squared, which that is going to be your LCD. That is the lowest common denominator. Now you could just multiply 6x times 4x squared to get 24x to the third, and that is a common denominator. But it helps get the lowest common denominator. Let me show you how this works. We're going to rewrite this problem. So I'm going to write x minus 5 over 6x. Got a plus, and I got 3, 4x squared. Now what I want to do is I want to create common denominators. And I want both bottoms to be 12x squared because we decided that being the lowest possible common denominator. So what do I need to multiply this by to make it a 12x squared? Well, hopefully you notice 3. And you do that top and bottom. The reason top and bottom is because 3 divided by 3 is 1. And any number times 1, you don't change its value. You're just changing the way it looks. Because say you have 5 times 1, that's 5. So you're not changing its value, you're changing its appearance. Over here, I need to change this into 12x squared. So what I need to multiply this by, it looks like would be 2x. And the top by 2x. But this one I'm going to put by parentheses because I need to distribute the 2x times both pieces inside. So when I distribute the 2x times both pieces here, I'm going to get 2x squared right there. And 2x times negative 5, negative 10x. And on the bottom, as you can see, 12x squared. Now I got my plus. 3 times 3, go to 9. And the bottom is another 12x squared, which is what we were looking for, a common denominator. So what can we do when you have a common denominator? We can simply add the tops, or combine them according to what that says, and that one does say add. So when I combine it all, I get that on top when you combine both tops, and you leave the bottom. Now, you could try to factor the top if you could, and then try to cancel some more, but this is actually the answer for this one. Sometimes you want to try to factor the top again and see if something else cancels. Just like with a problem in general, with fractions, you always want to reduce as much as possible. And you want to factor to try to reduce more. Okay, this next one. We're trying to get a common denominator. A little bit uglier here. You need to factor both denominators here because these are binomials. So the first one I look at and go, okay, how do I factor that? Well, the first thing in all factoring is pull out a greatest common factor. So I'm going to pull a 3 out of these two. When I pull a 3 out, I'm left with 3 times x is 3x. 3 times what is 12? It'll be 4. So this denominator is now 3 times x plus 4. This one, hopefully you catch on, it's called a difference of squares. So if you remember that one. So difference of squares, this is a squared, this is a squared. That's 4 squared. So that would be x minus 4 times x plus 4. Difference of squares, you always go, whatever squared gives you this, whatever squared gives you this, 1 plus 1 minus. So that would be the factored. Both bottoms are factored. Now, we want to find our LCD. So, like I said before, you choose one of the terms, all of it. Now, over here I chose the first one. I didn't have to choose the first one to start with. You could choose the second one and look at the next one to see what goes into it. You just want to choose one of the denominators to start off with. So, let's just take the whole first one. Okay, 3x plus 4. All right. Now, look at the next one is, okay, I don't need another x plus 4 in my LCD because they both have x plus 4, so why do I need to write it again? But don't I need x minus 4 so they both have something in common? Because watch this. Does 3x plus 4 go into this? And does x minus 4x plus 4 go into this? So again, all you do is you take one of them and then look at the other one to see what else you need. You don't need duplicates. Okay, that's my LCD. So here's what's going to happen. Let's give ourselves a little bit of space on this one because these can be a little tricky on how you write them. Okay, so we rewrite the first one, got the minus there. Rewrite the second one, put a parenthesis around there, you'll see why later. I'm writing the denominators in factor form. Alright, so to get this LCD, I need this bottom to look like that in the green. So what do I need to multiply this bottom by so it matches that? It looks like I need an x minus 4. Top and bottom. I'm going to distribute that in a second. And what does this one need so it matches this in the green? It needs a 3. So top and bottom by a 3. Alright, so now the bottoms are the same. I got to distribute the tops. So that's going to distribute. That gives me a 2x minus 8. Alright, the bottoms are the same, so I'm going to group them right away right now. 2x minus 8 right there. The bottom here, when you common denominators, are 3, x minus 4, x plus 4. And here, when you distribute the 3, I get 3x. 3 times x is 3x. 3 times negative 3 is negative 9. I have a common denominator, so I just grouped it right away. Alright, now I got to subtract the tops. So 2x, and you've got to be very, very careful with this, okay? Everybody kind of does this differently, but you have to probably, what I would do is you might want to change this minus to a add, and then distribute the negative, so that becomes a negative and that becomes a positive. That's how I kind of like to do it, because you're going to be minusing both these pieces, so I kind of change both of those. Anyway, so 2x plus negative 3x is negative x, or negative 1x, however you want to write it. And negative 8 plus 9 would be positive 1. The bottom is still 3, x minus 4, x plus 4. Then you see if you can factor the top and do any canceling. Alright, but you can't. So that is my final answer. Now you could write this as 1 minus x. Okay, so make sure you get a common denominator. Alright, the lowest common denominator. You might need to factor the bottom on a problem like this so you can see the denominators, see what would be the lowest common denominator. And then you combine the tops and leave the bottom. Now, one thing you got to watch out for. Some people think, oh, I can cancel the 2 with the 12, which is 1 over 6. I can cancel the x squareds. You cannot cancel pieces off because this is one whole term. You cannot cancel because it's one whole term. Just be very careful that people love to try to cancel these little pieces. Or like, oh, I can cancel this x with that. And they try to cancel all sorts of crazy stuff. You have to think of this as a term, a term, a term. And complete terms can only cancel that are connected by multiply. You can't just cancel out things when there's a plus or minus in between. They don't allow you to do that. So good luck with your fractions. Hope this helps.